Alright guys, here's your video for the Chapter 8 review slash practice test. So again, I think I've mentioned it in class, but we will have two portions on this test, one that is calculator and one that is non-calculator. So I'll first do the calculator and we'll do the non-calculator. Alright, so first one, find the value of the trig function indicated. So find sine of theta, and theta is right here. So sine, I know that this is going to be the opposite over the hypotenuse. So opposite side would be this side, and this would be the hypotenuse. So I know sine of theta is equal to the opposite side divided by 10. Alright, but I don't know what the opposite side is, so let's find it out. So let's call this side over here, we'll call it a squared. So we have a squared plus 9 squared equal to 10 squared. So that's a squared is equal to 100 subtract 81. So I get a squared is equal to 19. And then I take the square root, so I get a is equal to the square root of 19. So that's what the opposite side is, and that should not be a squared. Sorry, that should just be a. Okay, so sine of theta is going to be equal to the square root of 19 divided by 10. Alright, let's go on to 2. Find the cotangent of theta if sine of theta is equal to 3 over 5. So, I don't have a triangle, so let's just make one. Not going to be to scale or anything. I'll give this one theta, so sine of theta is equal to 3 over 5, because this would be opposite, that would be hypotenuse. And then we need to find this side right here. If you already recognize, this is a very simple triangle. It's called a Pythagorean triple. So this should just be 4. But if you don't know that, then we'll just use Pythagorean theorem. Call this a, so a squared plus 3 squared is equal to 25 squared. Or 5 squared, which is equal to 25. So a squared is going to be equal to 25 minus 9. So a squared is going to be equal to 16. Take the square root, so a is going to be equal to 4. Okay, so if that's the case, then cotangent of theta, cotangent is equal to the adjacent side divided by the opposite side, which is going to be equal to 4 over 3. So there you go. Okay, find the measure of each side indicated round to the nearest tenth. So here is the side that's being indicated. It's the x. Okay, so I have this angle right here. Okay, so I have angle B. I have the side that is opposite to it. And x is the hypotenuse. So which ratio gives me opposite and hypotenuse? That's sine. So sine of 34 is going to be equal to 16 over x. Okay, now let's solve for x. So let's get it out of the numerator. So let's multiply, or get it out of the denominator, and multiply both sides by x. So I get x sine of 34 is equal to 16, because these are going to cancel. And then I divide by sine of 34. So x is equal to 16 divided by sine of 34. Let's go ahead and calculate that. So 16 divided by sine of 34. Alright, so we get that x is equal to 30.24. Okay, let's try B. So for B, round to the nearest tenth, and let's do this one right here. So we have this angle right here. We have the side that is opposite, and we have a side that is adjacent. And which ratio uses the opposite and adjacent? Well, that's going to be tangent. So tangent of 31 is going to be equal to 13 over x. Same thing, we're going to multiply x's on both sides, so I get x times by tangent of 31 is equal to 13, and divide by tangent 31, so x is equal to 13 divided by tangent of 31. 13 divided by tangent of 31. Get, you know what? There we go. So we're learning as we go. This should be in degrees, so that's going to change my answer from the previous one. So check. So go back up here. Let's just redo it. So this is not right. So this right here, 16 divided by sine of 34. So 16 divided by sine of 34. And that's 23.25. 23.25. There we go. Let's try this one again over here. So 13 divided by tangent of 31. So 13 divided by tangent of 31. Tangent of 31. We get 21.64. Okay, so let this be a lesson to make sure that you're operating in degrees or radians depending on the type of measurement you're using. Okay. Find the measure of each angle indicated. Round to the nearest tenth. So this one we're trying to find the angle. So not really going to be all that different, but so we have this angle right here, and we have its opposite side, and we have the adjacent side. Okay, so we'll use tangent then. So tangent of theta is equal to 14 over 11. And in order to get tangent by itself, we will use a tangent inverse. Tangent inverse. So theta is equal to tangent inverse of 14 over 11. Please don't get this confused. Tangent inverse does not equal cotangent. They're not the same thing. Okay, so you just need to use a calculator. So tangent inverse of 14 over 11. So tangent inverse of 14 divided by 11. And we get 51.84 degrees. 51.84 degrees. So that's what that angle is right there. Alright, let's try this one right here. So I have this angle right here. I have the hypotenuse. And I have the adjacent side. So that sounds like cosine. So cosine of theta is equal to adjacent over the hypotenuse, so 5 over 7. And I want to use cosine inverse. So we'll use cosine inverse and cosine inverse. So those will cancel on the left, so we get theta is equal to cosine inverse of 5 over 7. So cosine inverse of 5 divided by 7, we get 44.4 degrees. 44.4 degrees. Alright, On to the next page. So draw the angle with the given measure and standard position. So we got, for this one right here, 615 degrees. So we know that we have an initial side, and then we have a terminal side. So the terminal side needs to go 615 degrees positive, so it needs to go this way. So first, what I'm going to do before I finish this, I'm going to see how many times can 360 go into this one, because I know I have to go 360, but then how much more do I need to go? So 615, and we don't need a calculator, we can just do some math. So 615 minus 360, so that's going to be 5, that's going to be 5, 1, that's going to be 5, that's going to be 255. Okay, so I know that this angle is going to rotate 360 degrees, and it has to go 255 degrees more. So this is 180 degrees. So how much more does it have to be than that? So this is 180, this is 270, so that's too far. So it has to be 15 degrees less, so probably right there. Don't forget that you need to show its rotation. So it's going to rotate 360 and then 250 degrees more after that. And there we have it. I'm going to double check with a calculator. So we have 615 minus 360, and we get 255 minus 180, get 75 degrees, which is 15 less than 90. So yep, so this would be 180, this would be 90, but 15 degrees less. So this right here is 75 degrees, so yep, that looks good. Okay, let's try this one right here. This one's in radians. Okay, so if it's in radians, first of all, I'm going to look at it like this right here, or like this right here. So pi ninths, that means each side has 9 pieces. So 1, 2, 3, 4, 5, 6, 7, 8, 9. You can think about it like that. Okay, and we need to go 17 pieces. So we have the initial side and the terminal side, which is going to go 9 pieces. Whoops. So this would be 9, and this right here, oh, 1 second, we're negative, so this is a negative angle, so we have to rotate counterclockwise. So this would be 9 out of 9. This would be 18 out of 9 pieces. So just 1/9 piece less than that, so maybe like right there. And it's going to rotate like that much. And there you go. That should be good. Alright, let's try this next one. Find a positive and a negative coterminal angle for each angle. So this means that I need to find something. So if I were to use up here as an example, a coterminal angle, if I rotated this angle, so it's already 615 degrees, if I rotate this back 360 degrees, then this angle would be coterminal. And then if I rotate it back, again, 360 degrees, coterminal, so on and so forth. So I need to add or subtract multiples of 360 degrees to the this number here. So negative 190 plus 360, so negative 190 plus 360, and negative 190 minus 360. So we got 170 and negative 550. So 170 degrees and negative, what was that again? 550. Okay, there you go. And for the next one, this one is in radians. So just note that your answer should also be in radians. So I'll do the same thing. I'll add 360 degrees, but the equivalency to 360 degrees in radians is 2 pi. So plus 2 pi. And I'll subtract 2 pi. However, this is not the same denominator, so I have to multiply the top and bottom by 3. So I get negative 4 pi divided by 3 plus 6 pi divided by 3. That's going to be equal to 2 pi divided by 3. Alright, and then again, negative 4 pi divided by 3. This time I'll subtract 2 pi. And that's going to be equal to negative 10 pi divided by 3. Alright, so there's one positive and there's one negative. Alright, here find the reference angle. So the reference angle using the terminal side is the angle measured to the closest x-axis. So that angle right there. And for 12 it'd be this angle right here. So theta prime would be equal to, well, theta prime would be equal to, well, we're going to have to take this 400 degrees and see how much this is right here. That's what we're going to need to do. So I think if we just do 400 minus 360, yeah. So this right here rotated 360 degrees. So this right here, I can't really see that. This here rotated 360 degrees. And so this right here would be equivalent to our theta prime, or our reference angle. So let's subtract 360 from that. And we're going to get just 40 degrees. And there you go, 40 degrees. Okay. Alright, let's try over here. So again, I'm looking for this angle measure right here. So note that this right here is measured in 18ths. So pi 18ths, that means each of these has 18 pieces. So this is 18. So when we went 18, then we went 36, right? Because 18 plus 18 is 36. Then we went another 18, and then however much more we went, we'll see. So pretty much, let's count up to that. So we went 18 and 18 and 18. So 18 times by 3 is equal to 54. So this right here is 18, and then that's 54. Okay, so how much more is this right here? That's what we need to find out, how much more that is right there. So 67 minus 54, and that's going to be equal to, that's going to be equal to 3, it's going to be equal to 13. Okay, so this right here was 18 and 18 and 18, which was 54, and then we went 13 more. Now how much would I need to go another one? So 18, 18, so that's 1, 2, 3, 4. So what is 18 times by 4? So 18 times by 4 is 72. So let's do 72 minus 67. Okay, let's see what we get right here. 72 minus 67, so that's going to be equal to 6. This is 12. That's going to be equal to 5. Okay, so this piece right here has to be equal to 5 pi over 18. That's how many more pieces it's going to have to go. So again, just to kind of recap, this one was kind of a more difficult one, which I like to give more difficult ones on the practice test so that the ones on the test are easier. But in any case, so this right here is 18, 18, 18, and then another 18 would be 72 out of 18. So we needed to subtract 72 from 67, and that gave us 5 pieces. So that's how much more I need to get to 72. So there you go. Convert each radian measure into degrees. So this is in radian measure, so let's convert it to degrees. So I want to get rid of this pi, so I'm going to multiply by the ratio of with pi in the denominator, and equivalency to pi is 180 degrees. So I'm really just multiplying by 1, but doing so in a way that's going to get rid of the pi and give me degrees. So this is going to be equal to, well, I need to do, so let's think about this right here. So 5 times by 180 divided by 4. And 180 divided by 4 is 45 degrees. Okay, so that's going to be 45 degrees, so I get 5 times by 45, so let's do that really quickly in here. 5 times by 45, that's 225. So 225 or 255? 225. 225 degrees. Alright, and now this one is in degree measure, and we want to get it to radian measure, so I'll do the reciprocal of what I just did over here. So we'll do times by pi divided by 180. Okay, so that's going to be equal to 330 pi divided by 180. Okay, which is going to be equal to 33 pi divided by 18. Those are both divisible by 3, so it's going to be 11 pi divided by 6. And there you go. Okay, down here, find the length of each arc and round your answers to the nearest tenth. So this is the arc that it's asking us to find, so right here. Okay, now the arc length is equivalent to theta times by the radius. This needs to be in radians. And lucky for us, it gives us the radian measure. So this is going to be equal to pi over 4 times by the radius, which is going to be equal to 3. So I have 3 pi divided by 4. Note that it's asking me to round to the nearest tenth, so it does not want it in terms of pi. So we're going to have to do this in our calculator. So 3 second pi divided by 4, and we get 2.36. So equal to 2.36. Don't forget your units of measurement. So 2.36 km. Okay. Let's see. Let's come down here. So, find the exact value of each trigonometric function. So, tangent of theta. So, here's our theta measure. Our theta measure is right here. We want to find the tangent of this one. Now, since it rotates more than 90 degrees, we are going to use the reference angle. So, here is the reference angle. So we're going to need to do 360, so 420 minus 360, and that's going to be equal to 60 degrees. So this is 60 degrees right here, because it had to rotate 360 and another 60 degrees to get to negative 420. Okay, so there is 60 degrees. Alright, so then what I like to do is to carve out or make a triangle. So here's my triangle. Right, so that triangle here we go. This is 60 degrees. That's a right angle. This is 30 degrees. This, okay, and then we just have to give the sine leg. So the shortest side is on the x, which is positive 1. And then down here, or the hypotenuse is going to be 2, and then this is going to be negative square root of 3. Okay, so we're measuring from this angle right here This is the angle measure we want to use from. So then tangent is equal to opposite over adjacent. And so opposite to this side is negative square root of 3, and adjacent is 1. So tangent of negative 420 degrees is going to be equal to negative square root of 3 divided by 1, which is just going to be negative square root of 3. Okay, let's see. So here we got this one. So this is 4 pi over 3. So since this is 4 pi over 3, this is 3 pi over 3, and this is only one piece more. So that means this one has to be pi over 3, this angle right there. So if you make your triangle from that, okay, so this right here is pi over 3. Now remember that pi over 3 is equivalent to 60 degrees. So if this is a 60-degree angle, then just note that this is special angle triangle. This side's going to be 2. This is going to be negative square root of 3. This is going to be negative 1. Yep. Okay. And then opposite for cosine. Cosine is the adjacent over the hypotenuse. Okay, so in this case, cosine of 4 pi divided by 3 is going to be equal to 1, negative 1 divided by 2. Okay, and then down here for cosecant of theta. Okay, so for this angle, we had to go 360 and then 180, and then that much more. So let's do 570. So 570 minus 360, and then minus 180. So that is a 30-degree extra rotation. So this right here is 30 degrees. So if you make your triangle, okay, this is going to be 30 degrees. Now opposite to 30 degrees is going to be 1. This is going to be 2. This is negative square root of 3. Cosecant is the reciprocal to sine, so it's going to be hypotenuse over the opposite. So in this case, cosecant of negative 570 degrees is going to be equal to 2 divided by 1, which is going to be equal to 2. Alright, let's go down here. Find the missing side lengths and leave your answers in radicals in simplest form. Okay, so this should be pretty easy. Most of you caught on to this pretty quickly. So we want to find what M and N are. Now note that these are special angle triangles. So this is 30 degrees and this is 450 degrees. Okay, so that means if this is a 30-degree angle, this is the shortest side, and this right here is the double that. So N has to be equal to half of that, so 7/2. And M has to be equal to 7 divided by 2 times by the square root of 3. Or you can write this as 7 square root of 3 divided by 2. Okay, so those are the values there. For 20, we have a 45, 45, 90 triangle. So this is 5 square root of 2. And so these sides right here, you can find by dividing by the square root of 2 and dividing by the square root of 2. And they'll be the same because it's a 45, 45, 90 triangle. So x is going to be equal to y, which is going to be equal to 5 square root of 2 divided by the square root of 2, which will be equal to 5. Okay, and so that concludes the calculator portion, and this is the no calculator portion.